Right, this example is looking at those two particular rules we've got, our interaction between events. So it's looking for the intersection and the union within this example. So clearly quite a greedy eater here. The probability that I have dessert with lunch is 0.2. The probability that I have dessert with dinner is 0.4. And on 10% of the days I have dessert with both meals. So our questions are, on what percentage of days do I have at least one dessert, and on what percentage of days do I have no dessert? Well, like the notes say, sometimes a Venn diagram can be useful in these, and even if it's just to give you an idea of what's going on. So what we are looking for, because we know that sometimes I have dessert with both meals. So we've got lunch and we've got dinner. When I have dessert, I might just have dessert with lunch, or I might just have dessert with dinner, or in here I have dessert with both. And this bit in the middle is referred to as the probability of lunch intersection with dinner. So this would be saying the probability that I have dessert with lunch and also with dinner. Out here, this is the probability I just have dessert with dinner. Out here is the probability I don't have any dessert at all. So let's try and see if we can match up some of the information in the question into a statement of some sort of algebra or probability statements. So dessert with lunch, I'm going to carry on like I was here, saying the probability of dessert with lunch is going to be shown by probability of L. So the probability I have dessert with lunch is 0.2. The probability I have dessert with dinner is 0.4. And I'm also told on 10% of the days I have dessert with both. Now with both, in the notes it tells us that this intersection sign, which you can remember because intersection, so we've got the intersection symbol in here. Alright, so with the probability of the intersection, we are saying it's A and B, it says in the notes. So that's lunch and dinner. So you can read this as and, which is another good way of remembering it. Okay, the probability of dessert with lunch and dinner is 0.1. So we've got a lot of information. Now we're wanting the probability that I have dessert with at least one meal. So I have at least one dessert. In my diagram, that's meaning all of that circle, and what's in the middle for the intersection. So there's a formula that we've got that says the probability of A union B, because that's both circles added together, is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now if we look at our Venn diagram, we can see why that would happen, because if we took the probability of L and added that to the probability of D, we would have counted this overlap bit twice. We would have counted it when it was in the L circle and also when it was in the D circle, which is why we have to subtract that intersection. So in this problem, we're talking about lunch and dinner, or one just at lunch, or one just at dinner. So if we look over here, this is dessert just at lunch, dessert just at dinner, or in both. And that's what it asks for, at least one dessert. So we just now need to put all of our information that we've got here into the equivalent formula. So the probability of a dessert at lunch and or dinner is going to be the probability of lunch plus the probability of dinner minus the probability of their intersection, because I don't want to count it twice in the Venn diagram. Alright, so the probability of lunch was 0.2, the probability of dinner is 0.4, and the probability of their intersection was 0.1. So that means the probability, or what percentage of days, because the question said, and what percentage of days do I have at least one dessert? So that would be on 50% of the days where I have at least one dessert. In the second part, it says no dessert. Now this relies on that idea of the complement again. So we've used our interaction of events, but now part B really wants the complement because it's saying no dessert. So that would be, and we can write this as the probability of the complement of having one or the other. So if we remember in our diagram, we talked about how the complement, which is having no desserts at all, would be this bit around the outside. So this stuff all around the edge. So if we took 1, because all probabilities have to add to 1, and we subtract what is the union, the stuff in the circles, which we found to be 0.5, then we now can find that the complement of having at least one dessert, which is having no desserts, is also 0.5. And since it asked for it in what percentage of days, we should also write that one as 50% as well.